Namaskaram. Welcome to the course Basics of Electronics. In this video, we will be looking into 555 timer IC in digital electronics. This video is divided into 5 important parts. First one is what are timers and why they are needed in electronics. Second one is all about 555 timer IC and its importance. Third one is applications of 555 timer IC in electronic industry. Fourth one is advantages and disadvantages of 555 timer IC. Last but not the least, fifth one is design of Astable multivibrator circuit using a 555 timer IC in Easy EDA tool. So let's begin. What are timer circuits and why do we need them? Timing circuits in electronics or digital electronics are designed to generate a timing pulses or delay with a specific duration. They are controlled by integrated circuits, resistors and capacitor, or maybe these timing pulses are generated by crystal oscillators. These timing circuits are very essential in digital electronics where there is a need of switching, controlling or sequencing. Because if you want to create a sequencing pulses, you have to create a time pulses with a specific duration. That's why timing circuits are very essential in digital electronics. Say for example, you want to create a time pulse of 1 second on period and 1 second off period. This is a very classic example of a medical shop board, which is a plus sign outside the shop. In that case, you have two options. One is using a microcontroller. When you use a microcontroller for such a small application, it is overkilling and very costly process. Instead of that, we use a small digital circuits like a 555 timer IC to generate a time pulse, which will make it easy and also possible to change the duration as per the requirement just by changing a couple of components outside. That's how the timing circuits in digital electronics are very important when it comes to ESDM industry. Now let's talk about the LM555 timer IC and its significance. LM555 timer IC is a digital electronic integrated circuit, which is used for generating a time pulses in digital electronics. This is widely used for sequencing and switching application where a timely dependent design engineering is required. It is a linear monolithic integrated circuit with a 8-pin IC structure with having a SMD and THD package in design engineering. It requires only 2 external resistors and 1 electrolytic capacitor to tune its turn on and turn off time, or you can say a width of the pulse and the space of the pulse at the output side. This IC can be used for a stable multivibrator, bistable multivibrator, monostable multivibrator and various timing applications in digital electronic industry. As I already mentioned about the sine mode outside the medical shop. It is very easy and straightforward to make a circuit which can work like a switching device in electronic industry by using a LM555 timer IC, and it has a very wide range of input voltage and output voltage capacity. That's why it is very suitable for DIY segment as well as industrial application. As it is also available in SMD structure, it can be used for compact device design engineering as well. Applications of 555 timer IC. As I already mentioned about this particular IC, it is very easy to build a circuit around it. That's why there are numerous applications in 555 timer IC industry as a whole electronic industry or maybe a digital electronics. Right now, I'll consider 4 to 5 applications and explain them for your understanding. First one is traffic light control system. Whenever you visualize the traffic light, you can see most of the things are run by timing pulses. And most of these timing pulses are generated by 555 timer based timing circuits only, because it is not necessarily need to be designed with a microcontroller in most of the cases. But where there is a complex system, then there is a need of microcontroller or a microprocessor with embedded systems around it. But in simple application and when it is not in working condition, the yellow light that blinks by default in idle condition is completely driven by 555 timer circuit inside. Second one is LED signboards. As I already mentioned about it earlier, all medical shop plus signs outside their shop is completely driven by 555 timer IC because it is very easy to design. When you use a microcontroller for such small application, it is not only the cost that bears you, also the design and development process is very costly and time consuming. That's why don't we use a ready-made solution, which is 555 timer IC, and just by tweaking the resistance and capacitance value, we can change the time pulse and width of the pulse, timing, and so many things. That's why 555 timer is by default used in medical shop LED signboards. Not only to that, most of the LED signboards are driven by 555 timer IC. Third one is servo motors in industrial application. We all know that servo motors work with PWM signal, which means pulse width modulation. This pulse width modulation signal can be generated by 555 timer circuit because it is precise and accurate. Most of the DIY segment servo motors are having a driver control inside, which is nothing but a 555 timer circuit. That's how the entire industry of DIY segment is having a very low cost servo motors for their DIY projects. Not only to that, if you go to industrial level, most of the servo motors are having a 555 timer IC as the pulse generator or a pulse width modulation circuit for driving them. Fourth one is signal generators in logic system. When you go for a laboratory or most of the small scale application where you need a specific signal like a square wave with a specific frequency, then you can use a 555 timer IC as an oscillator. Of course, we have a crystal oscillator and we have very precise RC oscillators, but most of the small scale application where there is no possibility of a high cost investment or the product of very low end application, then 555 timer IC is widely used in most of the application. That's why in logic analyzer and logic system, 555 timer can be used for generating the signals. These are the few classic example to understand how this 555 timer IC is very widely used in industry. There is no limit. We can explore hundreds of applications around this particular IC. Advantages and disadvantages of 555 timer IC. There are several advantages in this particular IC if you compare it with a discrete level of designing a time pulse generator. Of course, we are using integrated circuit. That's why we have a couple of advantages and couple of disadvantages. Let's discuss them one by one. Here are 5 important advantages for consideration. First one is LM555 timer IC can generate a timing pulses ranging from microsecond to an hour. Like you can literally generate a signal as speed as microseconds, and also you can generate a time pulse which can as long as an hour, which is awesome and very much suitable for various applications come under this particular category. Second advantage is this IC works with a wide range of input voltage. For example, 4.5 volt to 35 volt. Most of the embedded system work at 5 volt and most of the PLC work at 24 volt, and every automotive industry works at 12 volt. That's why the range from 4.5 volt to 24 volt is sufficient for DIY segment as well as industrial segment. Third advantage is it requires only 2 external resistor and 1 external electrolytic capacitor to tune its pulse width and pulse duration. That's how easy it is. That's why it is more popular in industry. Fourth advantage is this particular IC is available in various form factor and almost everywhere. If you go to the local shop and if you ask for a 555 timer IC, you will get it. That's why it is very advantageous for the design engineers to consider it for their design activity. Fifth one is this 555 timer IC is reliable and efficient in industrial environment, which means in a harsh environment and various environmental factor, this IC performs very well if you have taken care of the IPC standards and certain protection with respect to the environmental standards. Now let's talk about the disadvantages of this particular IC. First one is non-linear behavior of pulse duration or pulse width. The frequency setting of this particular IC is not linear. Though it is precise, it is not linear. By changing the resistance value and capacitance value, you cannot say it is linear curve. By just using a mathematical curve formula. You have to experiment and you have to calculate it with a proper formula to understand what particular frequency you are generating based on the resistance. Second disadvantage is the output will vary with respect to the change in resistance because of environmental temperature. These resistors are external, and if you are using a 5% tolerant resistors, because of environmental temperature change, the output frequency will change rapidly. The third disadvantage is TTL based ICs are more easily available in market, which means their working voltage starts from 4.5 volt. And if you go for a CMOS based IC, which starts working from 1.8 volt, which is not easily available in market. Though it is more popular IC, they are not available in market as easily as TTL circuits. That's why it becomes little difficult for the designer to consider them for a low voltage application. Fourth disadvantage is the output current of this particular IC is maximum to 200 milliampere, which makes it very difficult to use it for high load current driving. That's why we need to use external drivers or the switching devices at the output side to control the high load capacity signals. That's how this particular IC is having a couple of disadvantages with compared to any timing circuits in entire electronic circuit. Astable multivibrator design using a 555 timer in EasyEDA tool. This is how I'm going to demonstrate you with the help of EasyEDA tool how to design Astable multivibrator circuit by using a 555 timer IC which we discussed so far. So let's jump on the screen and explore this one. Before that, if you are not aware of what is EasyEDA tool and how to use it, then I have created a wonderful tutorial on PCB designing for absolute beginners in our channel called Link Frequency. So if you want, you can explore that, link in I button here. You can explore that and to understand how to design a schematic, how to design a PCB layout by using EasyEDA tool. Now let's jump on the screen to explore about it. First of all, we'll go to the file and create a new project. Now I will give this project as a name of LM555 timer circuit. So because it is a 555 timer circuit, right? I'll not give any description as of now for ease of understanding and ease of proceeding further. Then we will be having a canvas here on which we will be designing our circuit. Of course, we cannot simulate this circuit to understand how it works, but as of now, we can build a circuit to understand how exactly circuit looks like. I will change the name of this particular sheet as a schematic, and then we will be changing the name of this project title as LM555 timer circuit. And then of course, we will be changing our company name as Link Frequency. And I already have my name registered here as it is my account. So let's jump into the creating a circuit by using a LM555 timer IC. Now we have a two option here. When we go to the global library, if I search for LM555 IC, then we will be getting a two option. First option is a traditional standard IC symbol, which is like this. You can see here a tiny little icon somewhere there. You can see that it is traditional 8-pin architecture with a SMD component footprint. You can see that. That is one option. Another option is more suitable for Astable multivibrator design, which could be customized by ourselves, or we can use others developer IC which is already designed. For example, like this, which is already having an arrangement of pin to accordance with the Astable multivibrator circuit, which is more suitable for our application. So I'm going to use this one. Now I'll keep this U1 designator and the name of the IC at the top side so that it is standardized. Now we have very important pin structure here. 4 and 8 pin should be connected to VCC together. That's why those two pins are at the top side. I feel the 4th pin can be kept at the top side as well along with VCC, but that's okay, no problem. And we have a discharge pin here which is connected through a small resistor or maybe a 1/4 watt resistor from a reset pin to the 7th pin through VCC again, not through the resistor alone to the reset pin. And then from the 7th pin to 6th and 2nd pin short, we can connect one more resistor, and then 2nd pin to the ground with respect to one more electrolytic capacitor. These are the three important components which will decide the timing pulse width and duration of the output signal. Let me build a circuit quickly for you and explain further. I will use the VCC symbol here. I will connect that particular VCC here, and then I will be using one more VCC symbol somewhere here, which will make it easy for me to connect to reset pin. I can connect it directly to this VCC as well, but I'm using one more VCC. And then we need to use a quarter watt resistor with a through hole footprint, and I will keep that particular resistor somewhere here, which will make it easy for me to connect. And that particular resistor is given as a designator of R1 by default by the tool. And then I will use one more resistor which will be connected to 6th pin, and 2nd pin and 6th pin will be short. How do I get to know which pin to short with which pin and what is the circuit diagram? For that particular thing, you have to study the data sheet. I have given wonderful video what is the importance of data sheet and how to read the data sheet in one of my tutorial in PCB designing course. If you want, you can check it out after this particular video. But right now, when you study the data sheet, you will get to know what is the application note of that particular IC. In this case, 555 timer IC. When you study the data sheet, you will get to know how to build a Astable multivibrator with a typical application circuit as given for your reference. By using that reference, I am building this circuit, and I have used this particular circuit for more than 100 times in my industry products and in my college days. That's why it is very familiar with me and easily I remember this one. Now let me continue to create a circuit, and we have to add one electrolytic capacitor, and we are very sure that we will be adding at least a 16 volt capacitor. That's why I'm using a 6.3 diameter based capacitor, and we will be adding a ground here. And then we have a ground pin here, so we will be adding a ground symbol directly to the ground pin. That is straightforward. And at the point of CV, which is control voltage, we need to add one ceramic capacitor, which stands a value of 0.01 or maybe 0.1 microfarad. Obviously, so we'll connect a ground here and as well a ceramic capacitor. Now we are done with creating a basic circuit. By doing so, we will be generating a timing pulse at the 3rd pin of this IC, which is out pin. Now, to represent the output, we need at least one LED, or maybe we can connect it to any driver circuit to drive a heavy voltage load or heavy current load. Right now, I'll take an example of resistor and one LED. So I'll consider a quarter watt resistor, which is again a through hole technology. And then we will be using a one LED, maybe a 5 mm diameter LED of red color or maybe a green color. I'll just connect it somewhere here, and along with that I will be using a ground symbol, which is very traditional way of connecting output of this 555 timer IC with a LED. Now I will complete the circuit. This is how the entire 555 timer based Astable multivibrator will be designed. The only important thing right now left is tuning the value of resistor and capacitor, because that will decide the timing pulse width and duration. Hope you remember I mentioned about the possibility of time pulse generation with respect to 555 timer IC ranging from microsecond to an hour. That time pulse you can control by R1 resistor, R2 resistor and C1 capacitor. Usually what happens, we assume any two component and we tune the one component value with a formula of T on is equal to 0.693 into C1 into R1 plus R2. This is a T on formula. Similarly for T off, we can use 0.693 into C1 into R2 because the discharge path is only through this R2 resistor. This is how, using a T on and T off formula, we can calculate the complete T, which is a time period of the pulse. Most of the time by using a T on formula is sufficient. When we use a T on formula, we will get to know what is the R1 value and R2 value as well as C1 value. Right now, for ease of calculation, if I want to generate a 1.2 second of on period and 1 second of off period, which is total T of 2.2 second, then we can go with these three values, which is R1 is equal to 30 kilo ohm and R2 is equal to 150 kilo ohm and C1 is equal to 10 microfarad. How did I do this particular calculation? very straightforward. I given you a formula. You can insert any two value like R1 and C1 value and compute the R2 value, because T on is already decided by us, which is 1.2 second. Otherwise, you insert the value of R1 and R2 and C1 and compute the T on value. Anything is fine. Or else you can use the online calculator directly and compute that particular value automatically. After doing that, what will be the value of this particular load resistor? I usually go with a 560 ohm because I want to see this LED lit very bright. That's why I'll go with a 560 ohm. Again, it is your choice based on the voltage and current rating. This particular circuit now ready. We can use this particular circuit to generate a 1.2 second of on period, 1.1 second of off period continuously. Awesome, right? Until and unless you have a power supply to this particular circuit, it generates that timing pulses limitlessly. You can literally keep it on for 1 day, 2 day, 1 month, 1 year. It still works. Of course, there are certain rules and regulations or certain hardware design engineering to be considered while you are deploying it in a harsh environment or industrial application. But most of the time, it awesomely work or it reliably work in safer zone. That's how this 555 timer based Astable multivibrator circuit is designed in industry. Alright, this is all you need to know about timer circuits or a 555 timer IC in digital electronic industry. I hope you enjoyed the entire tutorial and the effort behind this particular tutorial. See you again in the next tutorial or video. Until then, happy learning. Namaskaram.